The rapid development of exoskeletons is opening up new possibilities in supporting work, rehabilitation, and industrial performance. At the same time, ensuring ergonomic and legal compliance has also become crucial. This is where the ViveLab Exo project plays a pioneering role. Hello, everyone. I'm Edith, and today's guest on Mind Talk is Csaba Szeredy, the development manager at ViveTech. Today, Csaba and I will be talking about the development of exoskeletons and the ViveLab Exo project. Hello, Csaba. Welcome to our studio.
Thanks for having me. Glad to be here.
Thank you very much for accepting our invitation. Could you tell us a bit about what inspired the creation of the software and what specific problem it solves?
The inspiration came from the fact that until now, exoskeleton manufacturers and users have not been able to objectively measure how much an exoskeleton helps them in a given workflow. The main problem was that only subjective feedback was available. For example, someone might say it felt lighter or more comfortable, but this did not reassure clients about whether investing in an exoskeleton would be a worthwhile investment. ViveLab Exo addresses this by providing objective measurements and ergonomics analyses based on standards, which we also validate with instrumented measurements from an independent research institute.
How does the software measure and analyze the interaction between the human body and the exoskeleton from an ergonomic perspective?
The system performs biomechanical calculations based on the motion data received about the worker's movements, focusing on the forces and torques acting on the bones and joints. Then it simulates how these values change or would change if the same sequence of movements were performed by the worker while wearing an exoskeleton or a specific type of exoskeleton. Based on the simulation, it can be determined which exoskeleton is the most optimal for the tasks examined and which one provides the most and best assistance in this process. The software uses the MyUse and NASA OB types of ergonomic standards for its calculations and compares the results to these benchmarks. This way, it can be demonstrated how much the use of the exoskeleton reduces the energy expenditure required by the worker to perform a given task.
Since we've already delved into the details, what data sources and technologies does the system rely on during its analyses? I'm thinking here about motion tracking, sensors, and AI-related topics.
Yes, as I mentioned, the basis of the measurements is that first, in some way, we need to digitize the worker's movements. And we assume that when they use the exoskeleton, they will perform the same sequence of movements, since it is the task itself that determines what kind of movement or movements need to be carried out. Therefore, we can expect that the sequence of movements itself will not change, meaning that the rotational position and the position of the human body's joints will not change whether the person is wearing an exoskeleton or not. So we can use this in our calculations. We also need the worker's body measurements, body type, whether they have an athletic or less athletic musculature, their body weight, whether they are male or female.
So there can be significant differences, I suppose.
Well, there can be huge differences, especially because in our calculations, we take into account the weight of each body part, since a person has to move their own body by itself. Plus, of course, there are the external weights and external forces acting on them. How big the object is that needs to be lifted, from where to where the object has to be moved, how many kilograms the given object weighs, or if an external device needs to be moved, if a lever has to be pulled or an object has to be pushed. The force required for that also has to be taken into account. And of course, after this, we use various artificial intelligence and other simulation algorithms to examine the human-machine interaction and try to predict what changes will occur in the different forces if a given worker uses a particular exoskeleton.
In which industries do you see the greatest potential for applying ergonomic analysis of exoskeletons?
At the beginning of the project, we identified three main target areas. The first is the traditional industry itself, where assembly, manufacturing, logistics, painting, installation, repetitive tasks, or overhead work are required. Healthcare and rehabilitation is another very important area. Here, the rehabilitation of musculoskeletal injuries and the support of physiotherapy is a very interesting area. The third area is military use, where soldiers need to carry heavier loads for longer periods, and exoskeletons can support various tactical loads as well.
Well, then the range is quite broad.
Yes, it's very broad, and unfortunately, in today's world, it's a self-perpetuating process, because where there is war, there is rehabilitation afterwards. So these two areas are interconnected.
What are the biggest challenges you've encountered in software development?
The first and most important problem is that accurate calculations require accurate data. You see, the human body is unfortunately a body that is extremely difficult to measure precisely. So in order to accurately measure the movement of a bone structure, the relative positions of the bones to each other. To measure their angles of rotation, you would first have to drill into the human body, hammer in pins, and take precise measurements for this purpose or attach sensors for this. Well, obviously, that's not possible. This is precisely the reason why we must utilize advanced digital motion capture and digitization techniques that effectively eliminate and mitigate these potential sources of error and include sophisticated mathematical optimization algorithms that allow us to obtain sufficiently accurate and highly reliable measurement data. Fortunately, we have been working on the digitization and simulation of human movement for more than 30 years. So we know hardware and software manufacturers who are capable of producing such devices, and we have used these in our previous projects as well. It is also very important that even if we measure and evaluate the data accurately, it is of little use if there are no internationally accepted standards against which we can assess them. So we had to choose physical parameters that we could get our clients to accept, even without these being defined in some standard by international scientific institutes. And on the other hand, from the user's perspective, there is also the acceptance of the whole exoskeleton topic, because everyone suspects that using an exoskeleton helps with work in some way, but no one really knows for sure. And we want to build a bridge between this suspicion and actual knowledge by preparing evidence-based reports that show how a specific workflow with a specific exoskeleton supports the worker. And in doing so, we hope to overcome this lack of acceptance.
Let's take a look into the future. How do you see this future? In what direction could exoskeleton technology and the supporting ergonomic software develop if we think about the next 5 or 10 years?
I believe that exoskeletons will become widespread and will spread extensively, not only in industry, but even in everyday life, and perhaps even for gardening. These could be useful in warehousing, agriculture, and healthcare. And ergonomic software will become standard tools during occupational safety audits. By combining artificial intelligence and digital twins, we will be able to provide accurate, personalized predictions about which exoskeleton is best suited for a given application and work task.
Let's take a look at the other side for a moment. How do you ensure that the software complies with the various relevant industry standards and all kinds of legal regulations? I'm sure there's a lot to consider on this side as well.
Yes, as I mentioned, there are no actual standards for the analysis of exoskeletons, but in ergonomics, there have been accepted standards for 30 or 40 years. For example, the ISO 11226, NIOSH, OWAS, and Mazoba standards. These are what we use during evaluations, and we apply their assessment methodologies when we evaluate the support provided by exoskeletons. In addition, we also take into account occupational safety regulations that pertain to the use of external support devices. Of course, when it comes to health data, we apply the GDPR requirements and strive to anonymize the data to ensure that this does not cause any issues.
How do you see the maturity of the exoskeleton market?
The market is currently in a developmental phase. It is already being actively tested in industry and logistics, but we are still before its widespread adoption. The most important areas of application today are warehouse material handling, assembly, and support for assembly operations. In the next 5 to 10 years, I expect a breakthrough in both military applications and rehabilitation. There are already positive signs of this. So for example, in connection with the wars in Israel and Ukraine, and in terms of preparing for rehabilitation after these conflicts. And I believe that the effectiveness of exoskeletons will directly result in improved quality of life or increased safety in these areas.
Thank you very much, Csaba, for being here with us in the studio today. It was very exciting to hear about these developments and about the future plans expected in the world of exoskeletons and in this market. And we wish you the best of luck with these projects.
Thank you very much, and thank you for the invitation.
Thank you very much.